Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, system of particles and rotational motion, chapter 7, ncert solution, part 8. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever any video is uploaded by us, so that you should not miss any important information or any important video tutorial. Let us begin today's lesson. Today we'll start with question number 7.24. A bullet of mass 10 gram and speed 500 meter per second is fired into a door and gets embedded exactly at the center of the door. The door is 1 meter wide and weighs weighs 12 kg. It is hinged at one end and rotates about its vertical axis, without practically without friction. Find the angular speed of the door and just after the bullet of the find the angular speed of the door just after the bullet is embedded into it. So this is the question. The important summary will are underlined in blues. So from this we'll create the step 1 of the sum, that summary, what are given and what we need to find. Let us solve the sum. So step 1, we need to write the summary means the values which are given to us and the value which we need to find it out. So mainly we write the value which are known to us from the sum. So mass of the bullet, that is m, is equal to 10 gram, which will convert into kg, that is 10 multiplied by 10 to the power minus 3 kg. Velocity of the bullet, that is v is equal to 500 meter per second. It is already in SI unit, so no need to do any conversion. Gram is not in SI unit, so we have converted to kg. Thickness of the door L is equal to 1 meter. So L is equal to 1 meter. Now radius of the door R is equal to half meter. Next, mass of the door, capital M, is equal to 12 kg. So this is step 1. We have written all the summary, what all the known values. Now step 2. Step 2. Step 2 is, first we'll find the angular momentum. Angular momentum imparted by the bullet on the door on the door. Angular momentum alpha is equal to mvr. So you have to remember this formula first. If you if you need to solve the sum, you have to remember this formula. So you have to remember this formula. So angular momentum is equal to mvr. M is the mass of the bullet, v is the velocity of the bullet, and r is the radius of the door. Now put the values. So m is equal to 10 into 10 to the power minus 3, v is equal to 500, and r is equal to half. Upon solving, we get 2.5 kg meter square second inverse. This is equation 1. Now, once we get the angular momentum, now we will find the moment of inertia. So step third. Moment of inertia of the door. Moment of inertia of the door. This we need to find out. So moment of inertia of the door I is equal to 1 by 3 ml square. Now we'll put the value here. We'll put the values. So 1 by 3 m is equal to 12, L square is equal to 1 square. Upon solving, we get kg 4 kg meter square. But now one more step, that is step 4, equate angular momentum. Equate. What to equate? Angular momentum, a relation between moment of inertia and angular momentum. This also is a formula, alpha is equal to I omega. So you have to remember. Now just therefore you can write omega is equal to alpha upon I. Put the values. Alpha's value we have found out, I's value we know, and upon solving we get 0.625 radian second per second, and this is the angular velocity. Our next question is 7.25. Two disks of moment of inertia I1 and I2 about their respective axes, normal to the disk and passing through the center, and rotating with an angular speed omega 1 and omega 2, are brought into contact face to face with their axis of rotation coincide. coincident. A. What is the angular speed of the two disk system? B. Show that the kinetic energy of the combined system is less than the sum of the kinetic energies of the two disks. How do you account this loss of energy? Take omega 1 is not equal to omega 2. So let us see the solution. So question number 7.25. Now, moment of inertia of the disk, no, first we'll write the steps. So first step is summary. So step 1 is summary. Summary of the sum. So what all are given? Moment of inertia of inertia moment of inertia of disk I is equal to I1. Moment of inertia is given. Now angular velocity, angular speed of disk 1 is equal to omega 1. Again angular speed mm, no first again moment of inertia of disk 2, moment of inertia of disk 2 is equal to I2. Again angular speed of disk 2 is equal to omega 2. Angular momentum of the disk. Now step 1 we have written whatever is given in the problem. Now step 2, in small step we'll do this sum. Find angular momentum. Find angular momentum. So we can write angular momentum is equal to angular momentum of disk 1 of disk 1 is equal to L1 of disk 1 L1 is equal to I1 omega 1. Again, angular momentum of disk 2 L2 is equal to I2 omega 2. Now I2 omega 2. Now total angular momentum. Total initial angular momentum is equal to, or I can write L initial. L initial L initial is equal to I1 omega 1 plus I2 omega 2. Why this? This is because when two disks are joined together, their this is the total initial angular momentum. Now, in the next case, what we can see, when two disks are joined together, the moment of inertia will be added. So, we can write step 3. Step 3. When two disks are joined together, when two disks are joined together, so what happened? So moment of inertia will be the addition of moment of inertia of the two disks. So I is equal to I1 plus I2. Next, let W be the angular velocity. So total final angular momentum. So when disks are joined together, find angular momentum. Momentum. Now total final angular momentum will be equal to L final is equal to I1 plus I2 I2 bracket omega. Now, using the law of conservation of momentum, we can write, so we have found the total angular momentum when the disks are joined together. Now, in step 3. Now, in step 4, we'll find out, in step 4, in step 4, we'll find out, find omega, means angular velocity. Here we have considered, let the total angular velocity be omega, this one. So we have to find the value of omega. So how can we do that? Simple, just use the law of conservation of angular momentum. So using the law of conservation of angular momentum, using the law of conservation of angular momentum, we have L initial is equal to L final. Instead of L initial, we can write I1 omega 1 plus I2 omega 2. Instead of L final, we can write I1 plus I2 omega. Therefore, we can write omega is equal to I1 omega 1 plus I2 omega 2, I2 omega 2 upon I1 plus I2. So this is the value of omega. Part A is solved. Now part B. Part B, step 5. So for part B, we'll find out the kinetic energy for disk 1, kinetic energy of disk 2, and initial kinetic energy of disk uh, initial total initial kinetic energy of disk 1 and disk 2. So find total initial kinetic energy of disk 1 and 2. So kinetic energy of disk 1 E1 is equal to half I1 omega 1 square. Again, of disk 2, disk 2 is equal to E2 is equal to half I2 omega 2 square. Total initial kinetic energy total initial kinetic energy E I is equal to E1 plus E2. Putting the value of E1 and E2, we get EI is equal to half I1 omega 1 square plus half I2 omega 2 square. Now we can write half I1 omega 1 square I2 omega 2 square. EI is equal to. Next, when the disks are joined together, the moment of inertia gets added. So case step 6, when the disks are joined together find final kinetic energy of the combination. Okay. Now, when the disks are joined together, the total moment of inertia will be I1 plus I2. Let angular speed is equal to omega. Final kinetic energy will be energy. Final kinetic energy EF is equal to half I1 plus I2 omega square. Now half I1 plus I2 omega, we have found omega's values here in our previous A. We have found the value of omega. Yes, we'll put this value of omega there. So I1 W1 I1 omega 1 plus I2 omega 2 upon I1 plus I2. We'll put it here. So it will be I1 omega 1 plus I2 omega 2 upon I1 plus I2 whole square, which is equal to, so one of this will get cancelled, I1 plus I2, one will be left here. So here in total we can write I1 omega 1 plus I2 omega 2 whole square upon I1 plus I2. That's it. So therefore E1 E initial minus ER EF. So kinetic energy initial minus kinetic energy final is equal to, put the values, so we have to write the steps here. Now step 7, find the difference between the kinetic energy initial and kinetic energy final. So what will be the difference? So difference, just we'll put the value here. We'll put the value here, EI minus EF is equal to, we have to find this, so half I1 omega 1 square plus I2 omega 2 square minus I1 omega 1 plus I2 omega 2 whole square upon 2 I1 plus I2. Now half I1 omega 1 square plus half I2 omega 2 square minus half I1 omega 1 square upon I1 plus I2 minus half I2 I2 square omega 2 square upon I1 plus I2 minus half 2 I1 I2 omega 1 omega 2 upon 2 I1 plus No, half is already there, so I1 plus I2. Now what we can take common. I1 plus I2 we have taken common, so what is left? Half I1 omega I1 square omega 1 square plus half I1 I2 omega 1 square plus half I1 I2 omega 2 square plus half I2 square omega 2 square. After that, minus half I1 square omega 1 square minus half I2 square omega 2 square. After that, minus I1 I2 omega 1 omega 2 bracket closed. So now we'll solve this. Now upon solving, we can write I1 I2 upon 2 I1 plus I2 bracket omega 1 square plus omega 2 square minus 2 omega 1 omega 2. So we can write here I1 I2 2 I1 plus I2 bracket omega 1 minus omega 2 whole square. Now all the quantities here in RHS are positive. Therefore, we can write E initial minus E final is greater than 0. E initial and E final is greater than 0. Therefore, we can write E initial is greater than E final. So, kinetic energy, initial kinetic energy will be greater than final kinetic energy after the combination of the disk. Now, the last part of the question is asking how will you define the loss? Okay, fine. The loss, uh, right? So, the loss of kinetic energy of kinetic energy, the loss of kinetic energy can be attributed to the frictional force that comes into play comes into play when the two when the two disks come together. When the two disks come in contact with each other. And this is the end of the sum. This is the end of today's session. Please subscribe, like, and share our channel. Please click on the subscribe button to support us, and please click on the bell icon to get automatic notifications so that you should not miss any of the tutorial. Please give us a like sign if the video was good. Thank you very much for your support and giving your time.